science classroom. Today's topic is matter in our surrounding. सबसे पहले आपको ध्यान देना है टाइटल के ऊपर में. ये चैप्टर नंबर 1 है और इसका टाइटल है मैटर इन आवर सराउंडिंग. तो आप अगर ये मैटर इन आवर सराउंडिंग पहले इस टाइटल को अच्छी तरह से समझ लें तो आपकी आधा चैप्टर पूरे समझ में आ जाएंगे. तो इसमें है क्या? सराउंडिंग, अराउंड यू, आपके चारों ओर, आप जहां रहते हो उसके सराउंडिंग चारों ओर में है क्या, वो है मैटर. तो आपके चारों ओर में जो भी चीज आप देख रहे हो, व्हाट एवर द थिंग्स यू आर विजुअलाइजिंग, यू आर फीलिंग, आर मैटर्स. फॉर एग्जाम्पल, एयर, you can feel it. Temperature, you can feel it. This is marker pen, you can see it. This is whiteboard, green board in your school, blackboard in your school, wall, table, chair, fan, cow, animals, leaf, plants, whatever it may be, stone, sand, etc. They are all coming under matter. So matter, whatever the name I have told you, things I have just narrated you, all have a common thing, and that common thing is they have space or they occupy space. Clear? So anything that occupies space is matter and is present around you. Is it clear now? So one more thing you have to note, this matter not only has the space but also they have volume and they have mass. Mass in the sense it is weight of the substance or weight of the matter, and volume means how much space that matter is occupying. Clear? So the unit for this volume is liter or cubic meter. If it is a solid, then you can measure the volume of the matter in cubic meter, m cube. If it is a fluid, then you can measure it through liter. While mass in both the case it is same, measured in kilogram unit. Clear? So this is what the basic of your matter, that it has space and it can be measured through volume as well as through mass. Clear? Before to the beginning of this science, Indian philosophers have already discussed about the types of matter, and they have fixed there are 5 elements of matter like air, water, fire, earth, sky. They are the 5 elements of matter as per Indian philosophy, and this is also supported by Greek philosophers. But the modern science tells that there are 2 nature of matter, or matter has 2 properties, or say 2 nature. One is called chemical nature, another one is physical nature. Chemical nature is a big topic, so we will discuss afterward. Today we are going to discuss the physical nature of matter. So here I have listed, there are 6 points of physical nature of matter. I am going to read out this. First one is matter is made up of particles. The particles of matter are very small. There is a space between the particles of matter. So they are the 3 points that tells everything about the nature of matter, that is particulate nature of matter. We will see some activities to find out these 3 physical properties of matter. Fourth one is the particles in matter are in motion. Fifth one, the particles in matter have kinetic energy. And sixth one is the particles of matter have force of attraction. So this point number 4 and 5 will here also will work out through activities. There are 3 activities are there to work out these 2 properties, and the 6th one, here again we will see 3 activities to find out these important properties of matter. So let's see the properties, let's see the activities through which we can find out this nature of the physical nature of matter. So first property is, take 100 ml of water in a beaker, right? Marker must be there in that beaker. Put 1 tablespoon of salt in it and observe what is happening to the level of water. Is it rising? No. If the level is not rising, then where is the salt? सॉल्ट गया कहाँ? पानी का लेवल ऊपर नहीं गया तो सॉल्ट क्रिस्टल जो थे वो गया कहाँ? आप सॉल्ट की जगह शक्कर भी ले सकते हो, दोनों केस में एग्जाम्पल सेम रहेगा. गया कहाँ? इसके आंसर ये है कि द वाटर पार्टिकल्स एंड द सॉल्ट पार्टिकल्स, they are intermingled with each other or intermixed with each other. It means the particles of matter have space among them. So within the space of water molecule or water elements, water particles, the salt particles enter into it, occupies into it. That is why the level of water does not rise. Clear? Then come to another experiment to see how tiny is the particle of matter. Activity number 2. You will just take 5 beakers. In first beaker, you will take 100 ml of water, and in remaining 4 beakers, you will take 90 ml of water. Okay? So take some crystal of potassium permanganate. The chemical formula is KMnO4. It is some pink color crystal. So drop few crystals in first beaker where you have taken 100 ml of water. Stir it. You will see the total water of that beaker changes to pink. Clear? Now put it. Now take 10 ml from that beaker and transfer it to next 90 ml of water. You will see that beaker, that second beaker will also change its color to pink. Then take the 10 ml of that solution from second beaker and put it in third one and repeat the experiment. You will see the last beaker water also get colored with pink. But what you will see, there is a gradation of color. The first one is darker and the last one is lighter. But you will see the pink color gradation. What happened? We have taken a small crystal, but once it go on dilution for 5 times, in all times it is diluted in water and it gives color in all cases. It means these particles are very, very small. Am I right? That proves that the particles of matter are very, very small. And these small particles enters into the space between the particles of other and they intermix with each other. So this is another property which you have discovered. Due to this space, these two matter get intermixed, and these properties of matter is called diffusion. Clear? Diffusion, as in the first experiment, salt get diffuses in water or sugar get diffuses in water. In the same way here, potassium permanganate crystal get diffuses into the water particles. Clear? Next come to the particles in matter are in motion. Take another example. Take out an incense stick. What will you observe? Can it smell? No. Now you light it. Once you burn this, the molecules, the particles comes out and it's spread throughout the room. Means the particles of matter are in motion. Second example, we will take same potassium permanganate solution. take a big crystal, put it in a beaker of water. What will say? At the point of drop of that crystal, the colors will come out and move into the beaker. Means these particles started moving in the water beaker. It also proves that the particles of matter are in continuous motion, right? The particles in matter have kinetic energy. Obviously, kinetic means energy for motion. So they must have energy, that's why they are moving from one place to another. So take one more example here. Take two beaker. One in one you will take hot water and another one you will take cold water. Clear? Now in both the beaker, put one crystal of potassium permanganate. You will see the hot water beaker shows high grade of motion of particles in comparison to the cold water beaker. It proves that once the temperature increases, the kinetic energy of the particle also increases. The particles in matter have kinetic energy, it is proved. Now, once you have taken the hot water, means their temperature is more, so the temperature increases, kinetic energy of the matter also increases. Next come to the particles of matter have force of attraction. Now these particles of matter, they have held together. That's why they gives the shape of a matter. Take example. You divide your friends into four groups. First group, they put their hands back, and from the back side they will hold the hands back of each other and make a chair. Second group, just you hold hands of each other and make the chair. Another group only holds the finger and make a chain. You will tell the fourth group to break them. Which group will break first? Obviously, the students who hold their fingers. Then the hand chain. But the first group cannot be broken because they are firmly bonded. And the group which breaks first, they are loosely bonded. So in the same cases, different matters have different kinds of force of attraction among their particles. जिस particles का force of attraction कम है, वो जल्दी टूट जाता है, और जिस particles का force of attraction बहुत ज़्यादा है, वो जल्दी नहीं टूटता है. Which keeps them together. So force strength varies in different matters. जिसके पास ज़्यादा attraction है, वो ज़्यादा force रहेगा उसमें. Clear? Now take one more example. Take nail, chalk, and a rubber band. With the help of hammer, you hammer it. Which one will break first? Obviously the chalk. Here, loose force of attraction. Nail, it will not break easily. So here, high force of attraction. You know one more experiment you can do? You can do one more experiment. Take a beaker, filled with water, and try to cut the surface of water with the help of a knife. Are you able to cut? No, you can't cut. At the initial point you will see a line, but later it will again rejoin. That also proves that the particles have a force of attraction. So that once they get disturbed, the force of attraction again came into being and they came to their normal position. So this is all about your physical nature of matter. Next see, states of matter. What is states of matter? Matter किस अवस्था पे रहता है? States of matter. हाँ, एक जरूर सोचना, क्या आपने वीडियो को सब्सक्राइब किया कि नहीं? नहीं तो अभी करें, ताकि इसके आने वाले टॉपिक आपको मिलते रहें. और लाइक शेयर करना ना भूलें, कमेंट भी अवश्य करें. So, states of matter. Depending on the particles, nature and behavior, the matter is of three types: solid, liquid and gas. Say some example of solid. You know very well this whiteboard is a solid, chalk solid, marker solid, sugar solid, salt solid. Liquid, water, oil, gas, very common thing in your house, CNG, through which your mother cooks food for you. So there are some examples of states of matter. Let's discuss point wise and how these points vary in these three different states of matter. First point is the shape of the matter. So as far as the solid matter is concerned, they have a definite shape and definite boundaries. See, this is the shape of this whiteboard and this is the boundary. 4 feet in length and 3 feet in breadth. This is solid. It is a cylindrical one. It is fixed shape. It is fixed volume. You can measure the volume as well as its mass. But in case of liquid, no definite shape and boundaries. Liquid don't have any shape or boundaries, but it has fixed volume. But one most important character is that once it is kept in a vessel, किसी चीज में हम इसको रख देते हैं, then it will take the volume as well as the shape, as well as volume and shape of that container. जिस कंटेनर में हम इसको रखते हैं उसी कंटेनर का शेप और वॉल्यूम ले लेता है. क्लियर? Here no shape, no boundaries and no fixed volume because they can be compressed. Once डब्बा खोल दो, it will expand like anything. Yes. So that compressible character we will discuss somewhere else. We'll again discuss. We'll compare the compressibility of gas, liquid and solid. So no shape, no boundary, no fixed volume. Third point. It can't flow. Solid cannot flow. Hence it is a rigid. It has rigid character. Fixed here. Can flow. Who? Liquid can flow. Hence not rigid and called fluid. Remember, fluid means the things which can flow. Gas is coming under fluid. So fluid is a broad term. You cannot say liquid is equal to fluid. Right? Liquid is a part of fluid. Gas is also a part of fluid. So fluid means both liquid and gas. The things which can flow is fluid. But it has a feature, it has a character that it will flow from up to down. It cannot flow from down to up. Here it is not rigid, can flow, hence called fluid. Flow in all directions. It can flow up to down, down to up, right to left, left to right, corner, diagonally, in all directions it will flow. Oh, gas. Then fourth point. It may break under force. Solid can break. When we apply a force, it will break. As in our previous experiment, we have broken chalk, but with difficulty we break the nail. Rubber, once we pull it with excess force, it will break. Liquid, you can do all these features, all this force you can't apply on liquid and on gas. So it cannot break. And you will not get any result if you apply the force on gas and liquid. 5. High force of attraction between the particles. The particles are packed in solid. So they have high force of attraction due to which they are in solid state. Here force of attraction is moderate, less, and here the force of attraction is very, very less. So the gas particles are flowing in nature. Next point is 6. Particles are fixed, tightly packed. See this diagram, solid, it is extended diagram is given there. Particles of the solid is very closely packed. Next one is liquid, loosely packed, and gas is far apart, and you will see the gas molecules are in motion. So they can strike each other. They can move randomly from here to there. So this is what the particles are fixed, tightly packed in solid, loosely packed in liquid, and free and shows random movement and hits each other as shown in the diagram. Next, least rate of diffusion. Solid particles cannot diffuse unless and until a liquid medium is given. If you have taken a salt in the first experiment and you will put this salt in sugar, they can diffuse. But once you put it in water, they get diffused. So, but very few cases are there where diffusion is there. For example, camphor, डामर गोली जो घर में आपकी मम्मी लोग साड़ी में रखते हैं कीड़ा नहीं लगने के लिए, गोल गोल सफेद वाले आते सेंट स्मेल करता है, that is an example of solid. So the solid has least rate of diffusion, liquid has higher rate of diffusion, whereas gas has highest rate of diffusion. Now that's compressibility. Solid cannot be compressed or very least compressibility is there. Liquid has moderate compressibility, whereas gas has high rate of compressibility. Take the example. Take an activity. Take 3 syringes through which injection is given, as shown in the diagram. Take out the portion, needle portion. Take out the needle and you plug it. Okay. Then in the first one, put chalk and push the piston. In second one, take water, do the same thing, take water, and in third one, nothing you will take. Okay, you push it. What you will observe? In case of solid, the piston cannot be pushed. In case of liquid, piston is very less, pushed very less. But in third one, it is high rate of pushing is there. It shows that gas can be compressed, liquid very moderate rate of compressibility, whereas solid has no compressibility or least compressibility. Solids you can store in any vessel, without any vessel. You can store anywhere. You can keep like this. Here I have hanged this blackboard, whiteboard. But you cannot follow the same procedure for liquid. You cannot hang liquid here or a gas here. It will flow down. Gas will flow in all direction, but it is fixed. So you can store it any place you like. This can be stored in a liquid, can be stored in a vessel. Solid can be stored, but it requires a closed vessel. पूरे बंद टाइटली पैक्ड वेसल होगा तब आप उसको स्टोर करोगे. लास्ट बट नॉट लीस्ट, solid has least kinetic energy, but their particles are not moving, they are very compactly packed. They have moderate kinetic energy. Liquid, solid has high rate of kinetic energy, so they can move randomly from here and there, and they strike each other. The particles of gases strike each other, and they itself gain their energy of motion, and that is called kinetic energy. It's self-generated by the gas particles. So this is all about your states of matter. Beside this, the modern research shows that beside these 3 states of matter, 2 more states of matters are there. Fourth, I can say it is 4th states of matter, that is plasma, and there is 5th state called Bose-Einstein condensate. These 2 categories you will read in higher classes. So this is all about your physical properties of matter and states of matter. Next class we will see interconversion of matter with temperature effect latent heat of fusion and latent heat of vaporization. The most important topic, next one, don't miss it. So please subscribe this one, like it, comment it and share to your friends, and wait for my next video. Thank you.